All right, let's get right into it. Think about some of the most important machines in your daily life. The ones that keep your food from spoiling and your house cool. Deep inside them, there's this hidden component, this unsung hero that's fighting an incredible battle against some really impossible odds. And today, we're going to tell its story. So, let me just ask you a question to get us started. If you had to guess, what do you think is the hardest working fluid in your home? What even comes to mind? Water, maybe? The gas in your car's tank? Well, it's not your morning coffee, although for some of us that's a very close second. The answer, believe it or not, is this highly specialized oil that's silently circulating inside your refrigerator and your air conditioner. That is our unsung hero. And look, this isn't just any old oil you can grab off a shelf. It is the absolute lifeblood of the compressor. And the compressor is basically the heart of any cooling system. Seriously, without this oil, the whole thing would just seize up and grind to a halt in a matter of minutes. But here's the catch. To do its job, this oil has to survive in one of the most hostile environments you can imagine. And when I say hostile, I really, really mean it. We tend to think of our fridge as this calm, quiet box, right? But for the oil inside, it is a non-stop, brutal battle for survival against some truly extreme forces. First off, check out the insane temperature range this stuff has to handle. At one moment, it's getting blasted by searing heat right at the compressor's discharge point. I mean, it has to withstand that without breaking down into useless sludge. But then, just moments later, it's traveling to the coldest parts of the system where it's facing a legitimate deep freeze, and it still has to flow like a liquid. It's a wild ride. And the temperature swings, that's just the beginning of the nightmare. This oil is also getting zapped by high-voltage electricity coming off the motor. It's under constant, incredible pressure. Even a single tiny drop of moisture becomes a major villain. It can freeze solid and completely block these tiny, critical little tubes. And on top of all that, it has to mix with chemical refrigerants without having some nasty reaction. It's an absolute gauntlet in there. So you have to be wondering, how on earth does this oil survive all that? Well, it's because it's not just oil. It's a masterpiece of chemical engineering. And to fight off all those threats, it's been designed with what I like to think of as 4 distinct superpowers. Superpower number 1 is chemical stability. This is its power of pure endurance. It means the oil has this incredible ability to resist breaking down under all that intense heat and pressure. And this is so critical, because in a lot of modern compressors that are hermetically sealed, the ones you can't just crack open for maintenance, this stability means the oil has to last for a decade or even longer without ever failing. Okay, next up, dielectric strength. Think of this as its force field. It's the oil's ability to be a fantastic electrical insulator. Remember all that high-voltage electricity from the motor? Well, this property is what prevents the whole thing from short-circuiting right through the oil. It literally keeps the electricity where it's supposed to be, so the system runs safely. Its third superpower is a very, very low pour point. This is its secret weapon against that deep freeze problem we talked about. The pour point is basically the absolute coldest temperature the oil can get before it just gives up and stops flowing. If the oil were to get too thick and turn to wax, or worse, freeze, it would clog everything up, starve the compressor of lubrication, and boom, you're looking at a catastrophic failure. And that brings us to the final and maybe most crucial superpower of all, viscosity. Now, viscosity is just a fancy word for a fluid's thickness, or, its resistance to flowing. And for refrigeration oil, getting the viscosity just right is an incredibly delicate balancing act. This is the classic Goldilocks problem. If the oil's viscosity is too low, if it's too thin and runny, it won't create a strong enough protective film between all the moving metal parts. That leads to friction, wear and tear, and eventually failure. But if the viscosity is too high, if it's too thick and syrupy, the compressor has to work way, way harder just to pump it around. And that wastes a ton of energy. It has to be engineered to be just right. So, we've established this oil is one tough fluid. But all those superpowers are totally useless if the oil can't actually get to where it needs to do its job. So that brings us to the pretty clever ways these systems actually handle lubrication. For the most part, there are 2 main methods. In smaller compressors like the one in your home refrigerator, they use a really simple and low-cost method called splash lubrication. It's exactly what it sounds like. Little scoops or dippers on the moving parts dip into a pool of oil at the bottom and just splash it everywhere, coating all the parts that need it. But for bigger, more heavy-duty compressors, they use what's called forced lubrication. This is more sophisticated. It's a tiny built-in oil pump that actively forces the oil through little channels to exactly where it's needed most. All right, there's one last really important piece to this puzzle. It's inevitable that a little bit of this oil is gonna get picked up and carried away from the compressor by the refrigerant gas that's flying through the system. Now, if too much oil leaves and doesn't come back, the compressor will run dry, and that's bad news. So engineers came up with a very smart device to fix this problem. It's called an oil separator, and it works on a really simple principle of physics, inertia. So the hot mixture of refrigerant gas and tiny oil droplets flows into the separator. Inside, the chamber gets wider, which slows the flow down, and then it forces the gas to make a super sharp turn. Now, the refrigerant gas is really light, so it can make that turn no problem. But the oil droplets are heavier. They have too much momentum, so they can't make the turn. They just slam into a screen, fall to the bottom, and get piped right back to the compressor where they belong. It's simple, but it's incredibly effective. So here's the big takeaway. The next time you grab a cold drink from your fridge or feel that cool air from your AC kick on, just take a second to remember this unsung hero. This perfectly engineered fluid is in there fighting off extreme heat, cold, pressure, and electricity, all to make sure your appliances run efficiently and reliably for years and years, saving you energy and preventing expensive repairs. It really gets you thinking, doesn't it? What other invisible, brilliantly designed heroes are out there working tirelessly behind the scenes just to make our modern lives possible?